All right, this question right here, it's saying in how many ways can a committee of 5 members be chosen from a club of 25 members? This is combinations here. Because it's a committee, the order does not matter, so we're going to say 25C5. And we'll just type that in the calculator. And that comes out to 53130. All right, next up here, it's asking in how many ways could 4 books be chosen from a group of 7 different books. So it does say chosen, so that kind of implies to me that order doesn't matter. Because it's not like we're putting them in a row or arranging them in any way. We're just picking 4 books. So it's going to be 7C4. So out of a group of 7, we're choosing 4. So once again, I'll just type that in the calculator. And that gives me 35. All right, next up here, it says how many different 5-card hands can be dealt from a deck of 52 cards. So a 5-card hand, order does not matter. And that's really because once you pick up your hand, you can rearrange it really however you want. So I would say for this one, order does not matter, which means we're using combinations. So out of 52 cards, we're going to do a combination of 5 cards and see how many that gives us. And that's 2, 5, 9, 8, 9, 6, 0. All right, next up, number 17. I'll let you guys try this. You can see once again it involves combinations. All right, next up here, we have from a class of 29 students, 7 are chosen to go on a field trip. The number of different ways the 7 students can be chosen under the given conditions. So this does sound like combinations. They're just getting chosen to go on the field trip. It doesn't matter the order. But on part A here, they say, actually, I'm going to do part C first. There's no restrictions. So really, if anybody can go here, it's just going to be 29C7. Because out of the 29 students, we are doing some combination of 7, and the order does not matter. So I type that in the calculator. I get 1, 5, 6, 0, 7, 8, 0. All right, so then the next one, I would say we could do this one next. Jack must go on the field trip. Well, if you kind of think about it, there's only one way that Jack can go on the field trip. And then what that would mean is that there's 28 students. I'm assuming Jack is one of the students, so I'm taking him out of this. And we're only choosing 6 there since Jack is already getting chosen. So like I said, that one up front, obviously not really relevant here, but just to show, this is saying that there's only one way that Jack can go. If there was more than one way that Jack can go, then we'd multiply that by 28C6. But in this case, it's just 1. So we'll type this in the calculator, and this gives me 376,740. All right, and then next up here, it says that Jack is not allowed to go on the field trip. So that means now we're choosing actually 7 students, but we're only picking out of a group of 27 because we're excluding Jack from that list. But we still do need 7 students to go. So it's going to be 27C7, and we get 88030. All right, next up here, it says solve this using the appropriate counting principles. So I'm just going to see how it goes here. So a group of 21 aspiring thespians, and this is kind of, I think, the more important part here, 6 men and 15 women, the way the rest of this problem is going. So we need a leading man, and so I'm just going to go ahead and draw a line here. So we got leading man. Okay, we'll also need a leading lady. And a supporting male role, and then supporting male, and then we have a supporting female, and then we also have, and I'm gonna actually have to do these like way back here. Actually, I'll do it up here. 2 women extras and 3 men extras. All right, so to fill these out, I'm just going to start off kind of with the fundamental counting principle. And so I know that for the leading man, we have 6 men to choose from. 6 men to choose from, all right. And then the leading woman, we have 15 women to choose from. And then once we have those 2 cast, we only have 5 left, 5 males left for the supporting male and 14 left for the supporting female. And then where it gets tricky here is back for our extras, 2 women extras and 3 men extras. So for these, we actually need to use combinations because it doesn't matter the order I pick the extras in. So from the women, we have 13 women left, and we're going to do some combination of 2 of them. And then for the men, we have 4 men left, and we're going to do some combination of 3 of them. So I'm just going to type that in the calculator here and see what I get. Just a sec. So I get 1,965,600. So obviously your numbers will be different, but that's the setup there. All right, next up here, we're going to do a combination. You could do this in your calculator as 5C2, or if you want to do it by hand here, the formula is for NCR is n factorial over r factorial times n minus r factorial. It's really kind of the same thing as the permutation one, except you have this extra r factorial down there. So what I'm going to do then is I'm going to do 5 factorial on top over 2 factorial times 3 factorial. And then I'm going to go ahead and expand the top, but I'm only going to expand it until I get to the 3 factorial. I always do the bigger one here so I can cancel that out. That still does leave me with a 2 factorial on bottom, which is really just 2 because it's 2 times 1. So you can cross cancel a little more, and that should just come out to 10. All right, next up here it says 12 people wish to play a hockey game. How many different ways can a team of 6 players be formed? So this is going to be a combination here because it doesn't say that order matters here. We're just trying to get people on a team. So I would just say it's 12C6. So you can type that in the calculator. All right, next up here it says a student has 6 math books, 4 history, and 7 science fiction. And how many different ways can they be rearranged? All right, so I'm first going to do this just kind of in the order they give it to me. So math, and then history, and then fiction. And so how many ways can I arrange these? So that's suggesting that order does matter. And so I'm going to use permutations here. So for just the math books, I have 6 P6. And then for just the history books, I have 4 P4. And then for just the fiction books, I have 7 P7. And I'm going to multiply all those together. However, I also kind of need to multiply this by a bigger choice here, which is what's going to be the order of these 3 things down here. And so to take that into account, I'm actually going to multiply this whole thing by 3p3, kind of suggesting now that, oops, I wrote that wrong. It should be 3p3. This kind of suggests here that there's 3 categories, and I'm going to put them also in some order of 3. So the individuals need to be put in order with permutations, and then also the group as a whole. So let me type this in the calculator and see what I get. All right, so I typed that all in. I get a huge number here, 522,547,200. All right, next up here it says a football team has 3 centers, 10 linemen who play either guard or tackle, 4 quarterbacks, 5 halfbacks, 5 ends, and 5 fullbacks. All right, so we need 1 center, 2 guards, 2 tackles, 2 ends, 2 halfbacks, a quarterback, and a fullback. Okay, so what I'm going to do here is we're going to do kind of lines here. I'm going to do one for the center. And so we have 3, and we're choosing 1. And then this is going to get multiplied by the guards. So for the guards, we are from the guards, let's see, we are taken from the group of 10 linemen, and we're choosing 8 of them. And then for the tackles, oh wait, we're not choosing 8 of them, excuse me. We're choosing 2 of them. And then for the tackles, we only have 8 left from these 10 because 2 of them are playing guard. And so out of the 8, we're going to choose 2. So that one you have to decrease it because they're kind of coming from the same group. All right, and then we need what do we need next? 2 tackles, got it. 2 ends. And so how many ends do we have? We have 5, and we're going to choose 2. And then we're also going to multiply that by the halfbacks. So we need 2 halfbacks, and out of a group of 5. And then we need a quarterback, so I'll multiply that down here. Our QB, and we also need a fullback. So for the quarterback, we have 4, and we're going to choose 1. And for the fullback, we have 5, and we're going to choose 1. So you multiply that all together, and I get 7,560,000 different combinations. All right, next up here, we got a committee of 6 men and 3 women. Is to be chosen from a group of 12 men and 10 women. To determine the number of ways we can select the committee. So we're going to have to separate the men and the women here. And for the men, we have 12, and we're choosing 6. And then the women, we have 10, and we're choosing 3. And we're going to multiply those two together because everyone from here has to match up from everyone from there. I don't need to double this because I don't need to switch the order of the men and women because they're all kind of going on to the same committee. So I'm just going to type it in like this. And when I do that, I get 110880 combinations. All right, next up here, it says a group of 30 students. A committee is going to select 30 students from a group of 900 to receive scholarships. How many ways could the students be selected if the scholarships are worth the same amount or a different amount? So same amount here, really what that's trying to tell me is that order does not matter because everyone's getting the same amount. I wouldn't care if I got picked first or last. Whereas this one, being a different amount, order does matter. And so really that is the difference between the permutations. So this one is going to be 900p30. And this one up here will be a combination. It will be 900c30. Oh, quick note on this. It looks like they want us to write it in scientific notation. So I will go ahead and kind of demonstrate that. So even when I type this on my calculator, it says 9.8. Let's see, it says go 2 decimal places. So I'm going to say 9.80. And then there's a bunch of more decimals here. And then it says E55. And what that E55 really means is the scientific notation. So this is 9.80 times 10 to the 55th power. Whatever that is the power of 10. So you can put that right there. And then you do have to put the 9.80 because it specifically says 2 decimal places. All right, so then the green one here, same idea. If we did it with a combination. Actually, that would be a permutation, excuse me. So that one is going to be 2.60, and then there's more decimals, and it says E88. And so I would write that in as 2.60, and then times 10 to the 88th power. All right, next up here, it says in one type of poker, a 5-card hand is dealt from a 52-card deck. How many hands will have exactly 3 kings? So for this one, for a 5-card hand for poker, this is always going to be a combination. The order does not matter because you can always rearrange your hand. So then what I'm going to do here is I'm actually going to do a combination for the kings, and I'm actually going to do a combination for the other cards as well. And I have to multiply these together. So out of the 4 kings in the deck, because there are 4 of every kind of type of card, we want to choose 3 of them. But then for the other 2 cards in our hand, we have to choose from the other 48 that are not kings. So we're going to multiply those 2 together, and I get 4, 5, 1, 2. All right, next up here, looks like we have a sequence here, and it looks like a geometric sequence. So it says depreciation of the machine is 55%. So that's going to tell me my R is 1 minus 0.55 since it's as compared to last year. The original cost I'm going to call A sub 0 is 10,000. And then it's asking what is A sub 5. So I would set up my A sub n as the original cost times 0.45, where I'm getting my R there, and then to the power of n. So for A sub 5, I'm just going to plug in the 5 up there and see what I get. And I get 184.53. We'll round that to the nearest penny. All right, this one here, I kind of know already that there's 4 terms there because you can just count them out. If we're starting at the first term, then the last one needs to be A sub 4. This looks geometric to me. I'm going to check it out. Check out R here is any term divided by the previous term. So if you multiply by the reciprocal there, it comes out to negative 1 over 5. And then we'll just, to make sure it's geometric, double check that. So if I did 1 over 100 divided by negative 1 over 20, multiply by the reciprocal there, that's just a 1 right there. That would be negative 20 over 1, and that actually reduces to negative 1/5 as well. So I think this is geometric. So I'm going to say a sub n equals, let's see, we got a1 there is 1/4. I'm going to go ahead and put that in parentheses. And then r we know is negative 1/5. And then that's to the power of n minus 1. So that one goes right there. Double check always, make sure your variables match up. It is because I used the n. All right, next up here, it says this is an infinite geometric series. So we're going to find the sum. And so that's going to be a1 over 1 minus r. So I know that a1 is 2048. And then r, I can always do any term divided by a previous term. So this one gives me 0.75, or if you'd rather use 3 over 4, that's fine. I'm just going to use 0.75 here. So that's going to be 2048 over 0.25. That's really times 4 there if you think about it. And so this will be 8192. All right, next up here, we want to write this in summation notation. So it looks arithmetic to me, and I'm going to track the pattern here. So it looks like a consistent +9 pattern. So that means we're going to use the dn plus a sub 0, or the mx plus b, where my common difference is a positive 9. And then a sub 0, I'm going to back 9 out, so that would be negative 5. So I'm going to say this will be 9n minus 5. I can double check it, plug in the 1, I get 4, plug in the 2, I get 13. So I know that goes there. Now I just need to figure out what that last number is, so I'm going to set it equal to 661 and see what n comes out. So add 5 over here, so 666 equals 9n. Divide by 9. And that would be the 74th term. All right, next up here, this one looks like it's a consistent +10 pattern. So this is going to set up very similar to the last question. So I'm going to, or actually, this one you have to actually find the sum. So I'll stick with you on this. So we know it's got to be a sub n equals 10n, since that's our common difference. And then the 0th term would be negative 2. So I'm going to say 10n minus 2. We then need to figure out what this last term is. So once again, I'll set that equal to that last term, 14978. So 14980 equals 10n. And then we'll divide that by 10, which is 1498. And so now when we want to find the sum here, our arithmetic sum formula, n over 2 times the first number plus the last number. And we actually have all this information already. We know that the n is 1498. Since we're starting at 1, it's just that top number. The first term is 8, and then the last term is 14978. So yeah, I would definitely say we should do this on the calculator. So 1498 divided by 2 times the parentheses 8 plus 14978. And we get 11,224,514.